Hello learners, welcome to yet another session of Database Management System. My name is Ashish Jain. I'm an assistant professor at the Department of Computer Applications at the Bhopal School of Social Sciences. Let's begin this module. Let us now see what the outline of this module. We will start with the components of physical DBMS. Then we will look at the functions of database manager as well as database administrator. Then we will look at one-tier DBMS architecture and the two-tier DBMS architecture. So let's begin this session. A database manager has various components here. A database manager is a program. We are talking about the program, the component of the architecture of DBMS, not the database manager in person. So a database manager is a program module responsible for interfacing with the database file system to the user queries. It is the interface between the low-level data, application programs and the queries. So what happens, this DBMS manager is further divided into different components, like we have authorization control, integrity checker, we have command processor, query optimizer, then we have transaction manager, scheduler, then we have buffer manager and recovery manager. So these are the basic components of a data manager module. Let us now see various components or responsibilities of DBMS manager. First, interaction with the file manager in order to properly process the queries, integrity enforcement, security enforcement, backup and recovery, and concurrency control. Concurrency means if two or more people are accessing the same database at the same time, this is called concurrent operation. So it needs to be controlled in an efficient manner. This database manager translates various data manipulation language statements or DML commands into low-level file system command. That is, it provides interactivity with the file manager. Then we have the integrity enforcement module. Here, the data value stored in database must satisfy certain consistency constraint. That means we should ensure that the data which we are entering is correct. For example, the balance of a bank account never fall below a prescribed amount. For example, the minimum balance should be 1,000. And if similarly, the number of holidays per year an employee may be having should not exceed 8 or 13, whatever it is, depending upon the company policy. So all these checks, we should ensure that if these checks are at proper place, then our data should be very consistent. We should not enter the wrong data. Then security enforcement. Not every user of the database needs to have access to the entire content, obviously. So whatever data is related to that particular user query, it should be displayed to him. Other data is hidden from him. That is to enforce various security checks to ensure that correct data is shown to the desired person. Then backup and recovery. At the time when some failure occur, there should be proper disk and proper recovery backup mechanism so that our data which is present in our system is not lost, because data is very important. So you should ensure that we should have proper backup and recovery mechanisms. Then concurrency control. As I've already told you, when several users update or access the database concurrently at the same time, what happens? There should be proper consistency of data. Whatever data is shown to the users, it should be proper and updated so that there should not be any inconsistency in the data. Next are the other components of DB and database manager. We have authorization control, we have command processor, integrity checker, query optimizer. This is an important thing. Transaction manager, scheduler, recovery manager, and the buffer manager. So authorization control module. This module checks that the user has the required authorization to carry out a required function. By means of login IDs and other things, we ensure that only genuine and authorized users access the database. Command processor. Once the system is checked, the user has given a kind of a command interface through which it interacts with the system and finally carry out its process. Then we have integrity checker. Now for an operation that changes the database, the integrity checker checks that the requested operation satisfied all the necessary integrity constraints such as key constraints, etc. So in order to ensure that our data is correct, we should have integrity checker also that ensures that all the data is properly integrated and all the checks are correctly done. Then query optimizer. This module determines an optimal strategy for the query execution. If you have given a big query or a very complex query, then it should be processed in a very small amount of time. The query optimizer makes sure that query is properly evaluated and also the time required to process a query should be less. so that we can retrieve the data faster. The Transaction Manager module performs the required processing of operations of various transactions by maintaining tables of authorization, concurrency, and other things together. This is to ensure that one transaction is completed and our database is from one consistent state to the other consistent state. If a transaction fails in between, the condition should be rolled back and we should be reverting back to the normal position before the transaction occurred. Then we come to the scheduler module. This module is responsible for ensuring that the concurrent operation or transaction database process should not be conflicting with each other. So properly scheduling is to be done. Which query should be processed first, which query should be taken second, and so on. For this you require a scheduler module. Then we have a recovery manager. In case we have some kind of failure in the database, it should provide recovery from it. Then we have the buffer manager. This module is responsible for the transfer of data between the main memory and secondary memory such as the disk and the tape, so that we should not run out of the storage space. Now we come to database administrator, or we call DBA. Database administrator is the most important person who actually maintains and manages the database together. So DBMA administers the three levels of database and defines the global view or the conceptual level of the database. It also specifies the external view of the various users and application and is responsible for definition. This is important. He is responsible for definition and implementation of internal level routines, including the storage structure and access methods used for optimum performance of DBMS. DBA is also responsible for granting various user permission or access rights to access different parts of DBMS. These are the major functions of a DBA. First, schema definition, that is the design of database. Storage structure and access method definition. Schema and physical organization modification as well as the maintenance. The granting of authorization for data access, that is the passwords, etc. And integrity constraint specification. All these things are done by the database administrator. This is a brief of all the functions of a DBMS in details. Now we come to tiered DBMS architecture. We have already seen the three-level architecture. This is called a three-tiered model. We also have one-tier, two-tier, and obviously three-tiered model. So one-tier DBMS model has a client computers plus file servers inbuilt in a single system, so that this is an old version in which all the things are kept at one system. Then we have a two-tier which works on the principle of client and server. A server contains all the required details and client requests for the services of the server. Now we have the three-tier architecture which is followed by modern day DBMS systems. So it breaks, or it has divided the whole system into three levels. First is the external schema or the external level. Then we have conceptual schema or the logical level, and internal or the physical level. We have already seen this model in the previous modules. So this, and then we have n-tier. Depending upon the different complexity and uses of DBMS, we have n-tier. We can have in between these layers, we can still divide it into different levels. So we have n number of tiers or n number of levels. The basic idea of having an n-tiered architecture is to have a clear separation between the presentation, the logic, and the actual storage of the data. So this is why we have these many kinds of tiered architecture. Let us now see various steps in database access. How we access database, we have these steps which are followed. So these are the basic steps. First of all, we have the query. We have a DBMS user interface through which we enter this query in the system, and a response is given to the user. How? First, we put a query into the system. This query is read by the database manager. This database manager, based upon the kind of a query, it put a request for the specific record to the file manager. The file manager, what it does, it requests the specific blocks to the disk manager, and actually the disk manager takes back the data from the database where it is stored. Now, once it fetches the data, it returns back the block of the code that is required from the secondary storage to the disk manager. This disk manager, what it does, it finally sends the requested blocks to the file manager. This file manager again reply back to the higher level, that is the database manager. And finally, this data manager gives the response to the user by the use of the DBMS interface. For example, you want to fetch a list of students pertaining to a particular condition. So what happened? This this query is evaluated at different levels by the data manager, the file manager, the disk manager, and actually to the database where it is stored. Now the data is fetched and it is again represented by the system using the interface such that, because physically in what form we store data is separate from what it is actually represented. We use tabular format, and sometimes we don't use tabular at all. We use a kind of a graphical representation of the data, right? We want to have a graph of those students, right? So for this you have this, but this representation is separated by the actual representation. This is why we have a layered architecture. So this is how we have different steps in accessing the database. These steps are: first of all, any access to the stored data is done by the data manager. The user's request for data is received by data manager, which determines the physical records required. The data manager sends the request for a specific physical record to the file manager. This file manager decides which physical blocks of secondary storage are to be accessed. Then finally, it contacts the disk manager that retrieves the data from the database. And finally, this file manager sends the request of required to the data manager. Let us now look back what we have seen in this module. We have started with the components of physical DBMS architecture. We have seen data manager and its functions. We have seen DBA and its functions. We have seen 1 and 2 tier DBMS architecture, and also how database is actually accessed by the user to get the desired query processed, right? So I hope this module is beneficial for you. Thank you all for joining.